Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by Chris, Ranty, Mark, and Arwin. Good to have you all.
Hello, folks.
Good afternoon.
So what were you talking about in the break? I vaguely heard it while I was trying to sort out a problem with the link, which I'm 90% sure I've fixed, but I'm just going to check.
Oh, it was just something from the last show talking about the turbines, and is that information at 0 degrees, would it still be there, you know? And the best thing I can explain is that all the information will be there, but we don't have the technology to see through it at 0 degrees. We don't have the optics to do that. We can't resonate. We can't. If you're trying to fill a mountain of information, and a height of a mountain of information into 0.0001 of a degree, that tiny narrow band is imperceivable. You wouldn't be able to acknowledge it's there. It would be there, but we wouldn't be able to see it. It's just as simple as that. And I think that's what we were talking about. And compression, obviously, compression of the lower parts of the boat. They retain the length of the boat is retained. It's just the squashing happens from top to bottom. It doesn't happen widthways, which is why the ball has always been able to say, oh, well, it seems to go over the curve of the Earth because it disappears from the bottom up. Well, we've got a lot of things going on at the horizon, compression being one of them.
Yeah, so this is Chris. I would just like to say, and I have to go. I do have to go to work, but before I go, one thing we were saying in the break is, and I think it's really important. I see people complaining in the chat that, you guys are continuing to talk about this subject of showing these pictures, showing the turbines, and talking about everything Randy just basically said. But what I have to say to that is, while it is sort of monotonous, it's very important that this topic be discussed and understood, because this is the difference between a flat Earth and a round Earth. If everything that this group is saying is true, that you can really see these things, that it's not looming, that they're not mirages, etc., then the Earth is flat. If it's not, then the Earth is round. So we can't belittle the point and say, oh, we're just talking about this too much. It's a very important point. It's so important, in my opinion, that this literally could make the difference between what some people believe and what other people believe. So with that said, I have to go. Appreciate it, guys. I'll see you next time.
Thanks
See you later, Chris.
See you later, Chris.
Have fun.
It's
Bye-bye.
easy to disprove everything Ranty just said. That's
Hey,
the problem.
Hey, Brenda.
Hello, Jose.
Hey,
Morning,
Brenda.
guys.
Hello.
Right. Hi, Brenda.
Hello?
No, but it's all a matter in the end. If you are consequent with the globe and what you calculate the curvatures and all of that to be, then you must draw the conclusion that there is no other option than to conclude that it is all uniformly looming into a flat plane, with the consequence.
What does that mean?
Let me finish.
No, I'm just asking a question.
Figure out what that means. Yeah? If you're going to interrupt me, you're never going to find out what that means.
Go ahead.
Right. So if you want to really assume that it is a globe with the curvature according to the calculations, according to all of the math, then you have to come to the conclusion that it must all be looming into this optically flat plane, because otherwise you would see the curvature always and you would never see the far distant footage that we do. It would be physically impossible. So if the Earth is a ball, then it must all be looming into a flat plane. And if it is all looming into a flat plane uniformly everywhere all the time, then there simply is no use in trying to find curvature
Could you
visually,
could you
because
explain
it
that,
can't
please?
be there, because it will always be concealed by the looming effect,
Yeah.
bending everything into a flat plane. And
Could you
then you can
explain that? I don't
mistakenly see
understand.
some
Could you?
optical effects here and there and mistake them for curvature, but they're just optical effects. They are not actually that physical curvature, because the universal looming always applies. So
Could you
you can
explain to
never
me
see
what
the
loop?
curvature. It is impossible.
Yeah.
If the Earth is a ball, then it is absolutely always impossible to see, to observe the curvature. It's
Right.
impossible.
Could you explain to me what looming into a flat plane is? I don't understand what you say.
Well, it is the refraction R-based looming system. Because if the Earth is a
Is it
ball,
looming
then
or
we would never
refraction?
be
I'm
able to see that far as we see at any time. There would be no alternative conditions that would ever make it possible that you could see this far.
Is it
So it
looming or
must be looming, and that
refraction?
looming is basically bending light in a uniform manner, in an
Is that what
R-based
looming is?
uniform manner around the curvature, around the entire globe, making it
Hmm.
appear like it is perfectly flat.
Well, when I
As
look
we
up
see it.
looming, that's not what it says it is.
No, but I'm not talking about the local looming effects, which is a mirage type effect. It's very local.
Well,
That's different. I'm talking
I
about
don't know what you're talking about.
refraction-based, R-based, universal looming that
Refraction
bends
based R
all
based.
visuals
Hi,
into a flat
Alan.
plane.
Hi,
All right.
not bad yourself?
Good, good. Making sure it's you. Carry on.
So everything that Arwen just said was complete gibberish, because he doesn't know what looming is.
Yeah, I
He
do know
doesn't know
what
what
looming
R
is.
based
I do know
refraction
what looming
is.
is.
What is looming, Arwen?
Well, the looming, according to basic optics, miraging effects, refraction,
Addy, hello.
reflections, that type of looming is a
Oh, Addy.
visual. Yeah.
Addy, hello.
Addy, talk quickly.
Nope. Okay.
That's me, I
Looming
kicked him.
is a mirage type effect, which
No,
optically,
that's not what it is.
yeah, it is.
No, it isn't.
Displaces certain image upward usually, and yeah,
No.
it is like a fata morgana, a mirage type effect.
Hey,
Hey,
Plain Truth.
plain truth. And that is what that does, but
Right?
that
No,
is
that's not
just
what looming
local
is.
looming, and always that type of looming only applies in certain conditions. It applies very locally. It's never universal, but that's not the looming that I'm referring to.
Should
I'm
we
referring to
look up
the
the definition for
inevitable
looming?
looming that would have to be there if the Earth was a globe.
Should we look up the definition of looming then, Arwen?
Yeah, you can do that
Why
if
don't we
you
do
like.
that? Why don't you go ahead and look up the definition?
Why don't you look it up? Right?
Okay, I will.
You think you have a point? Okay,
Yeah.
you look it up. I know what looming has to be. Local looming, we see.
Local.
Yeah, local looming. Optical effects in a specific band of vision under certain conditions. That's local looming. And then there is the universal looming, the refraction R-based looming that must be there if the Earth is a globe.
So apparently, Brenda, you can just make stuff up.
Apparently.
Now, I didn't make this up. I don't know if you noticed, but we've been
Yeah, that's called
mentioning
gravity.
looming. We've been mentioning this
so-
looming for years now.
Yes,
You
you don't
came
understand
up with it. The ballers came up with it. You seem to be completely demented and are
James,
now
hello?
forgetting it all.
Hello,
Nathan,
hello.
can you hear us?
Yeah, you don't
We're
know what
only
looming
giving
is.
you
so
back
Darwin.
what you brought to us.
Look,
Okay.
colloquially,
Looming. It's
colloquially,
all
in,
looming into
Guys,
a flat
hold on, we've
point.
got
But
a
you
new
don't know what
guest.
it is, Darwin.
Yeah,
Can you
I
shut
do
up a
know what it
second?
is.
No, it
Can you
isn't.
shut
what
up?
I'm
it has
reading it
to
right
be.
now. I'm reading it on the wiki page, and it's not what you say it is.
Oh,
Yeah, but it's
really?
colloquially
No,
look it
read
up.
out loud
Hang
what
on.
it is then.
No, you look it up and read it for yourself so you can understand.
but it's colloquial to this hangout, this looming. That we know what we're talking about.
Yes, but
Yeah.
you can make anything up. Do you want to make your own language
No,
up?
it is a mirage type effect. The looming, the universal looming that I am basically explaining here, that must, under all circumstances, at all time, exist, be there.
No, it doesn't.
Yes,
It's just
it-
an atmospheric
it must
phenomenon that
be
occurs under
there.
certain circumstances, not every.
Yeah, I know
not
that.
all
but
the
it's
time.
the local looming I was referring to.
There's
That
no
is the
local
looming
looming. What
that
does
we
that
can
mean?
actually distinguish in observations that we have. Okay, we
Um,
know what regular looming is. This is not the
No, you
looming
don't.
that I'm
No,
referring
you don't
to.
even know what regular looming is, Arwen. Regular looming is like a magnification. Objects will appear slightly magnified, and this is due to it. This is an atmospheric effect. There's no such thing as local looming. That's just something you made up.
Now, I
And
say
you haven't
local
explained what
looming
looming
to
to a flat
distinguish from
plane
the
means.
refraction R-based looming.
There's
right?
no R-based.
I'm just branding
What
it
does that
slightly
mean?
different.
R-based looming.
Yeah, R-based looming.
So I've just asked Siri what looming is, the definition. It says looming is a term found in the study of perception as it relates directly to psychology.
Psychology?
No, it's a real effect. It's not psychological. Looming is apparent magnification due to atmospheric conditions.
Right.
So it says looming refers to a rapid expansion in size of every given image. As the image becomes increasingly large on the perceiver's retina, i.e. when the object looms, there is an atmospheric psychological response to perceive the object as it approaches. As it is an approach. Let's just read that again. Physiological response to perceive the object as an approaching object or surface instead of one that is stationary or receding.
Yeah, we're not talking about the psychology. We're talking about this is a real physical phenomenon that happens.
Optical.
Well, hold on, I've just gone to Wikipedia. You've said that it's Wikipedia, and I've gone to Wikipedia.
No, optic is optic. It's visual. It is light-based. It is not physical.
Light is physical.
No, light is not physical. Light is
Light
optical.
is not physical? It's
Light
optical?
is optical.
Arwen, can things outside the atmosphere loom?
Outside the atmosphere. Well, that depends if they have visual components.
What does that
Is
mean?
there something visual about it that you could perceive from within the atmosphere?
Do things outside the atmosphere loom?
Well, let's just say that you are referring to the stars or the sun or the moon, which you have to assume are physical objects out there that we can perceive because of the
Not all flat
heliocentric
earthers
system.
believe
Then
that.
yes, they would be subjected to looming. Yeah, they would.
That be local or regional?
The universal looming, the regional looming.
We have local, regional, and universal looming.
And
Oh,
territorial.
you do? You have three types of looming now? I didn't know that.
Local, regional, universal.
And territorial.
Territorial?
Yeah.
Were you in the TAs, Ranty?
Well, whatever type of looming it is, yes. Wherever
Weird.
the looming is taking place, it would indeed also displace any visuals that would be coming from outside of the atmosphere that are like across it, that are in
So
that very
Looming
region
displaces
where the looming is
visuals.
taking place. Yes.
Looming displaces visuals.
Yeah. Well, aren't stars, aren't the sun and the moon, are they not visual? Do we not see them?
No, they're physical. The sun and the moon are physical.
Oh, right. They're physical, but we see them. Right? No, wait. They're physical, but we don't see them. So we just have to imagine they're there and just ignore that we see these things, right? So they're just physical, not optical, right? Makes a lot of sense.
Well, optics is physics.
No, optics
Optics is not physics.
Physics isn't physical, though.
Eh?
Physics isn't
Yeah, you're
physical.
correct.
Physics isn't physical. You're playing a play on words here.
Yeah,
Physics
you're right.
isn't
You
is
tricked me.
completely
You
different
tricked
to
me. You
something
tricked the
that's
Dutch
physical.
guy. Very nice.
Ranty, I don't understand how physics isn't physical. Could you explain that to me, please?
You were making a play on words there and trying to compare and trying to twist Darwin inside out with your
Then
terminology.
explain to me how
no,
I
no,
got
no,
it
no, no,
wrong.
no, 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 because you said physics is physical.
No, I said that optics
Yes, you
is
did.
physical.
No, you didn't. That's why I pulled you up on it.
Optics falls
No,
under
There's
physics.
two separate things.
Optics
Physical
falls under
is
physics,
physical.
but
Yes.
optics is not physical. Yeah, indeed.
Optical phenomenon are physical phenomena.
No, they're not. They are fall under the physics. They are not physical. They are optical. They are light-based, non-physical.
Well, light is physical.
No, it's not, you freaking idiot. Light is not physical. Light is light.
Yeah, I know.
Doesn't have any
it's a
physical
physical
components
thing.
to it. It is
Yeah,
non-material.
it does.
It's
No,
light.
it's not.
It is light. It is non-material.
Light is composed of photons. Photons are real physical things.
Oh, really?
Yes.
Oh, yeah? Have you ever grabbed one? Have you ever collected them? You ever
Yeah, you can
stored them?
collect them. Yes,
Oh,
you
really?
can detect them.
Catch them all. Got to catch all those
Yes.
photons.
They're real.
Yeah, because you believe them, right?
No, because we can detect them. We can measure them.
How?
With
How do you do
sensors.
that?
You can measure photons. You can
Oh,
measure
really?
their
You're going to take
energy,
a very, very, very
and-
small ruler.
and you can measure how fast it travels.
No,
You
you
can
can
measure its
travel how
direction.
fast light travels. That's not how fast a photon travels, because you have to assume that light is a photon in order to do that. And you don't know if it is. You
Yeah,
just
we do know
presume
that
it
light is
because that is
photons.
what scientists tell you about it.
No, we
You
know
believe
that light
because
is
you love to
composed
do
of
that.
photons.
You love to believe all of these scientific theories that tell you things are balls because you
Hi,
love it
Brenda.
so much.
Brenda,
Fucking hilarious.
you can either trust scientists or a 40-year-old newspaper delivery boy. Which one do you want to select?
I'm gonna trust the smart people.
Whoever you want. You know, trust your own instincts. Decide for yourself. Don't trust Darwin. Don't trust us. Don't trust Brenda. Just decide for yourself. Be your own judge.
Well, that's fair enough. You should trust your ability to reason, logic, and thinking clearly is what you should trust. And we haven't heard any clarity from Ranty or from Arwen. Ranty is just as confused as Arwen because Ranty thinks that optics isn't physics. Isn't that correct, Ranty?
No, that's
I
not
said
what he said, you
physics.
stupid
I
cunt.
said physical isn't
No
physics.
need, Darwin. No more swearing, please.
You said
No
physical
need.
and physics were the same.
Yeah.
What he said is
Yeah, they are.
optics is not physical. Not optics is not physics.
I never
Physics
mentioned.
physics is the study of the physical world.
I
What
never-
else would it be?
I never mentioned optical.
Physical is not the same thing as
Optics.
physics.
Oh,
It's
well,
mixing
Ranty-
words. You're constantly mixing words to try to make us look stupid.
Oh, I don't have to do that. I just have to ask
No,
you
you
questions.
just have to lie about things because that's the only thing you got left.
So optics is part of physics. Physics is the study of the physical world. Light is a physical phenomenon.
No, it's not. It's an optical
So
phenomenon.
what physical things have you observed and brought to the table today to show us?
Me? I just ask questions. I use my reason and my ability to think clearly.
Really? When we had a conversation about R, you basically told me that you trusted a guy's discernment based on a shadow that he saw in the sky, on a light in the sky, and that's where you got radius from. Do you think that's logical and reasonable?
Yes, it is.
Well, that's fair enough. You can believe whatever you like. I see that as totally illogical and totally unreasonable to make a formological fallacy.
No, I didn't commit any fallacy.
He did. Formal logical fallacy. Affirming the consequent. If there is a shadow on the light in the sky, then that curved shadow must be caused by the Earth. We see a curve on the shadow, therefore the Earth is curved. It's an affirming the consequent.
It's a deduction.
It's an affirming the consequent formal logical fallacy. That's what it is.
Could you explain to me what a formological fallacy is,
Sure.
please?
If P, then Q, Q therefore P. If I eat a 12-inch pizza, I am full. I am full, therefore I ate a 12-inch pizza, even though I just had ribs for dinner. So that's called a formal logical fallacy. If I see a shadow, it means that that shadow is caused by the Earth. Yeah? Therefore the Earth is a sphere. I see that shadow, therefore the Earth is a sphere. It's a formal logical fallacy. I keep saying this to you, and you keep telling me it's a process of Hercule Poirot deduction.
Right. What you described is called affirming the consequent. And that's not the fallacy that we are committing. We're not committing any fallacy. We're not affirming the consequent. Right? So the logic is that light rays from the sun are parallel. And if you measure on a curved surface, vertical structures, sticks or towers, would cast shadows at that would have differing lengths on a curved surface. And if you measure those lengths, you can use some trigonometry.
Sorry, you just said on a curved surface. So you are assuming automatically that you are on a curved surface. Yeah? So that is where the logical break comes. That is your assumption.
What was that?
That was your assumption. You assume you're on a curved surface.
No, I didn't.
Yes, you did. You said, if I'm on a curved surface, there is your presumption. You presume the surface is curved, and then you make the trig.
No.
Yes! Stop saying no, dumbass. Yes, that is your presumption. You presume you are standing on a curved surface, then you make the maths.
No.
Yes! If we're on a curve, that's what you said.
That's not an assumption.
Oh, right. If we're on a curve, that's not an assumption. Oh, right. Well, if unicorns exist, that's not an assumption. It's just a statement, right? A logical deduction. We see droplets of poo-poo, therefore must be unicorns, right? Affirming the consequent. Formal logical fallacy. Hello?
No, it's not a lot.
Is any of this
Nathan,
sinking
you're
in?
Incorrect. It's objectively curved.
Sorry. Objectively curved. Do you want to show me that curve?
Sure.
Go on then.
Go look out your window.
That's the biggest pile of garbage I've ever heard. Look out your window.
Okay. You can see a curve everywhere. It's pretty clear as day.
Okay, that's an excellent proof of curvature, P. Thanks for that.
You're welcome.
I'll just derive R from that, will I? Just use that as my scientific evidence.
Well, I mean,
P. Mars says it. Look out your window. That's the best you've got.
Yeah. Yeah.
Really? That's amazing.
I can see it out. I can see it out my window myself.
Good for you.
You can't.
You believe whatever you
blind?
like, P.
Right, am I presenting, Nate?
What's your vision, Nathan?
Go
You wear
ahead.
glasses? Like what's wrong? Why can't you see
You're
it?
presenting, Ranty.
Nathan, am I presenting?
Yeah.
All right, okay. Brenda, you still here?
Yeah.
Right,
Yeah.
okay. So Nathan did this yesterday. He put this video out. He basically had a ball and he stuck 2 bits of Lego on it. And what we're saying is that these are the 2 turbines. So we have a big set of turbines in the foreground.
Nigger.
And the small set in the background further away. But can you see how they're on different, their angles are different if you was to run a line through the whole.
Nigger.
P, for God's sake, no need.
Oh, he definitely has a need for it.
Brenda, would you agree that this is how you should see it if they were built on a plane? Built on a sphere of Earth.
If what was built on?
If there was sets of turbines running off in the distance around the curve of the Earth, this is what we should see. We should see the.
No, that's not what you should see.
Let me rephrase it. There is a squared function when you look over an ever-increasing amount of curve because you're on a sphere. Would you agree that the measurement of the first set of Lego bricks compared to the second would be a squared calculation? Would you agree with that? Yes or no? That is what we are pointing out. It matches the mathematics and how
No,
you
that's
say...
not what you would see. This doesn't represent the windmills at all.
Yeah, it does. It represents them being. The point of this demonstration is to show that there is a squared function at play. The curve in the foreground is added to the curve in the distance. So you have the curve that you go over for the first set of wind turbines, then there is the second set. Now, isolated, they are all on the same amount of curve. If you were to spin this ball and look at them side on, they would all look like they have the same exact amount of curve distributed between them. However, the reality is such that it's a squared
kicking him, but he's
function.
coming back constantly. So.
It's a squared
Yes,
function.
probably a lot of
It's a squared function if you're on a ball. So the first set are less curved around the ball than the second set from a viewer location.
This doesn't represent the physical reality of the wind farm at all.
Well, it's actually an exercise ball with Lego on it. No, it's not to scale. The point of the demonstration, I'll speak slowly for you, Brenda, is to demonstrate that there is an increasing amount of curve as you go out at distance, because the calculation on a ball, which is this demonstration of a not to scale Earth, it's an exercise ball, demonstrating that we have an increased amount of curvature as you go further into the distance, exactly as the calculator describes, because it's a squared function.
8 inches per mile squared.
Sorry, why are you saying it's not a squared function? Hold on, let's hear Brenda's bullshit reason.
Is a constant.
No, that would be a hill. We don't live on a hill. It's a squared function. It's a ball according to your fantasy.
Yes.
Yes. So the ball demonstrates the increase of curvature based on the distance because it is an exponential function. Not an exponential, sorry. Keep getting that wrong. A squared function. It gets more bally the further you look. It's not a hill. It's not constant. It's a ball according to you religious zealots who deny perspective and presume R. Therefore, it will be more angled the further over the ball you go. It's fairly
Can I ask a
simple.
question about this image?
Let's talk about that constant.
Well, hang on. Let us just finish this question, because obviously the people in chat will have seen exactly Brenda obfuscating the very real demonstration that Nathan did, which these turbines, which are further around the curve, should have a different angle to this one here. So when I scroll in and show you that these are all lining up through the top of the hubs, might need a slide adjustment.
How far away is the leftmost turbine from the rightmost turbine?
The left to the right.
We did this image
yesterday. 2.1 miles.
2 miles.
2.1
How much
miles.
curvature? How much curvature?
Brenda clearly hasn't listened to what I just said. There is a squared function. While you globeheads want to tie us down to just how much curvature there is on the turbines themselves in their isolated position, that is not what we will be doing, because they are 20 miles away. The first ones are subject to less curve than the second set, because there is a squared function if we're on a ball.
Yeah, that's wrong, Nathan. You don't.
No, 8 inches per mile squared. The ball becomes more bally the further you look out. So while you need us to look at it in a 2 mile isolated section, Brenda, we won't be, because the second set, like the demonstration on the exercise ball, the second set are further around the ball and the maths are squared, because according to your religious faith, it's a ball. Right, Brenda?
No, Brenda.
Can I just talk to Moranti, please?
No.
Yeah, sure.
No, I'm talking.
This
Why do you want to just talk to
turbine here, this
Ranty?
last
Why is she
one.
just ignoring me completely? Everything I say about the
15
being
miles away.
increasing squared
How
function of
far
curve,
away
she's
is
ignoring.
that one on the left?
Why are you
And this
talking?
one
Shut up,
from the one
Brenda.
on the right?
Shut up. Shut up. The calculation is a squared function. The amount of curve increases with distance because, according to you, we live on a spherical surface.
That's
A
false.
Shut up!
Okay, hold on, just real quick. Brenda, do you not acknowledge the 1 degree per 69 miles?
Yeah, it's 1 degree every 69 miles.
Okay, so
everywhere on Earth.
is the second degree larger than the first degree?
Right,
Is the third degree, is the fourth degree, is the fifth degree? That's where you have to think about what Nathan is saying according to your model as he's talking about the increase of curve. That's what we're talking about.
That's not an increase in curvature.
Yes, it is. For the love of God. As you go further out in distance on a ball, it is a squared function. It becomes more bally the further you look. The calculation
No, that's just not true.
is
Okay,
a
it's not true.
squared.
Why
Why do you keep talking over me,
curvature
Brenda?
on a ball
One more time, Brenda, and I'll
is
kick
the
you out.
same
Don't talk
everywhere
over me.
on the
Shut
ball.
up.
just
Right,
want to
I am
finish my
talking.
point.
That means you shut up. It's a squared function. Everybody watching knows this. The more you go
Yeah,
over a
of course.
ball, the more curved it becomes. Everybody watching
aware that
understands
the
this.
function
And
has
shut
the,
up!
As a squared
Shut
coefficient.
up! Right, you've got one last chance, Brenda, and I'll kick you out. Don't talk over me. It's been demonstrated on the exercise ball. The further you go out on a ball, the more pronounced the curve becomes from your position. That is what was demonstrated on the ball, and that is not demonstrated in reality. There is not an increasing curve, even though the maths and the fact that a ball has an increasing amount of curve from your viewing function, and it is a squared function.
Right, Nathan, can I just finish this point with Brenda, because I think I've given the wrong impression about the distances. So when I said there was a 2.1 mile distance, there is between these big ones here.
Yeah, that's what I wanted to know.
Between them ones. But these ones in the distance, this small one in the distance is 23.7 miles away in total. And this one, the big one here, is a distance of 12.9 miles away. So it's almost twice as far away. So this exponential
Are you
curve,
listening, Brenda? Just listen for
yeah, just listen. So the straight line I've put through the top of these hubs, right? So they are in a straight line. So this should have a different angle. This wind turbine, this wind farm in the distance, which is another 12 miles back, should have a different angle. If we look at Nathan's video, it should, as it goes around the curve, it should show a different
Stop
angle.
saying no, Brenda. Right, he's in the middle of a
should
sentence
show a
and you're
different
cutting
angle.
the mic. Shut
No, it shouldn't.
up and listen. It's not a no. This is a fact of your fantasy ball religion. It's a squared function. A ball gets more bally the further you get out. Do not say no. He's in the middle of speaking.
So basically, those two blocks represent these two wind turbines, or these. They should show a different angle. It's the nature of the mathematics of your ball. This is what they should show. It should show a different angle. This angle in the background on this one, it should be more like so. It should be tilted slightly down as it goes around the curve.
Yeah.
So that's how it should look, something like that, where the angle would be pointing down. But the fact that it's actually in relation...
It is at it looks, oh, he had to change the angle. Huh.
No, he changed it to show you what it should be doing if it was increasing in the amount of curvature. So he's changed it. If it was a ball, i.e. it matched the maths, and we had this squared function. Stop, right, that's it, Brenda. That's your last chance. Get out. You can't help yourself. The ballers are being defeated, so they just talk over us continually.
That was difficult because she knew damn well that I didn't change the angle prior to putting left and right a couple of times. The only time I changed the angle was to try and explain when I did this now and lifted it up, was to say this is what you should have seen on the ball. You should have seen this kind of drop away. It should have been on a different angle. But the fact that they aren't proves that they've been built on a flat surface. They can't have the same angle. It's impossible for them to have the exact same angle.
Indeed.
But she wouldn't She wouldn't stay
Well,
long
there's no
enough to
curve.
let
If
us.
it's curved, it's curved. The near ones should be less curved than the far ones. There should be an increase in curve in the ones in the distance because it's apparently a ball. We don't see that. We just see a straight line on both of them because of perspective, something that's ignored in their calculations completely. As far as their calculations are concerned, all of these turbines are at the exact same height. In this picture, which is what they compare the maths to, obviously they're not the same height in the picture when you refer to the top and bottom line of the frame of the picture. They're getting smaller in the frame. Well, that effect, which is an optical effect of angular size reduction at distance, is ignored as far as the maths. They're all the same size. They just give you feet and inches from Wiki. That's all they ever do. So the effect of perspective, that's not even accounted for. But apparently, the curve, which is what this effect is according to the maths, the curve is more pronounced on the back ones than on the front ones. It isn't. There's no increasing squared function of curve at play here. There's just perspective. Nothing more, nothing less. That's it.
I think I got Brendan's response down.
Oh.
Well, you point out that there's a squared function, I point out that there's a squared function, and while you're in the middle of your sentence, you're saying no. It's like, why are you denying the nature of your own mathematics for your own fantasy religion? 8 inches per mile squared is something that almost every single flat earth and ball earther who comes into this debate understands implicitly. Yet she's saying no. No, it's not a squared function. No, they shouldn't be getting more curvy. Yeah, you should see more curve around a ball if you go further out. It's simple. 8 inches per mile squared, according to you retards who think you live on a ball.
No.
Well, yeah, I may be wrong here, but I know that the squared function does work as you're making the distance further, but if you're just talking about each position,
We're not. How many times did we have to say this to you in a 3-hour show yesterday? We are not talking about the distance between them in isolation. We are talking about the distance from the observer point.
I know.
Yeah, well, why'd you keep saying it then? It's about the 20th time you've said, oh, if we just look at them down a 2-mile stretch, there's not very much curve at all.
Well, just if you let me get past my point,
That's your same point as yesterday. We had it for 3 hours. If we just look down them as a 2-mile stretch and calculate them that way, the maths works.
No, Brenda didn't get to finish what she was saying. I think I kind of understood what she was trying to say, which is that this the squared equation that you would use would get you further and would help you know a distance further. But when you're talking about a relationship to each other, each post to each other post, which will give you the line that you're trying to make. So we are talking about a line coming from each post. You're not going to have to square those distances from each other. So that the curve's not going to square from those two. It's going to be the same measurement.
No, it's not. If you plot points on a graph and your equation you're using involves a square, it's not a straight line. It goes in a curve, and it goes a lot sharper and steeper the further away you go. And that is our point.
I agree that it's just going to get it's steeper.
Excellent. That's our point. It doesn't get steeper. We only see straight lines. Do you get it?
No, that's what I'm saying.
No, that's what we're saying. If it's a squared function, you should have a curve like you've just conceded.
No, I didn't say that.
So you think a squared function does not produce a curve. You think a squared function produces a straight line, do you?
In this case.
In this case, what, when we've got a photo of reality not showing it curve? Yeah, that's because the Earth is flat. It's got nothing to do with a squared function not producing a curved line. They do produce curved lines. Perspective produces linear lines.
You don't need the squared function in this case.
You've got a squared function. Your calculator. If you don't need it, why are you defying the calculator again?
Because we're talking about two different things now. We're talking about
we're talking about reality and curve mathematics. Those are the two different things. They don't match.
He's talking about the same thing that we were doing yesterday with the turbines being a third of a mile away from each other. He's shortening the distance so that if it's shorter than a mile, you don't need to square anything because it's not at a mile yet. That's what he's trying to justify.
Yeah, he wants to do it in isolation. They want to bring down the observation to just a couple of miles because that's how far the turbines are apart. They've seen an angle that they think they can work with us, and we're just not having it. No, it is not a 2-mile observation. It's a 20-plus mile observation. You should see the
Really,
squared
those lines?
function.
How long
Why
are
are
those
you now
lines?
talking over me?
Watch
Oh,
yesterday's
wait a minute. Hang on,
show.
wait a minute. Oh, I've got this, right? It doesn't matter how long the line is, right? If I had a building at 20 miles away and I had another building at 23.5 miles away, so I've got two buildings, the same height but different distances apart, what should be the drop that I see, or the hidden from my perspective?
Yeah, depending on the distance, you should see a drop. Yeah.
You're damn right you should.
Mm-hmm.
Yeah. So why would I need to calculate between the distances between the house and the 8 inch per mile squared? I wouldn't be doing 8 inch per mile squared between the two houses, would I? Because it's 8
No,
inch
but
per mile squared from my observer point.
yeah, but you still wouldn't see this curve. The
Yeah,
curve.
you would. The maths say you would. Why do you keep defying the calculator? The maths say it curves.
The Earth does curve.
Yeah, no, the Earth doesn't curve because the photographs, the only thing that we've got that's real world is not curving. Don't tell me the world curves. Your models curve. Your maths curve because they're using a squared function. Everything that you fantasize about the world being has curves. The reality, why do you keep talking over me? The reality is not curved. It's linear.
Okay, Nathan, at least entertain this so I can finish the sentence, okay? The distance you're talking about, the 23 miles, this is true. This is how you would calculate that difference. But when you're drawing these lines, and the lines is what you're using to find the curve, this is what you're using to find the curve, you're not going to find it there.
It's not there. There should be. Your model yesterday demonstrated that. You get quite close to them, right up close, so you're isolating them to the 2 miles. And did we see curve? Yes! In your model, just like the maths, we see a curve if it's curved. We don't see that, though. There is no curve. You keep saying there shouldn't be. There should be. Why do you keep telling us there shouldn't be a curve?
No, I'm just talking about this one. Also, I saw a few other models yesterday as well.
Not anyone.
Don't care about the models.
Can you present me, Nathan?
Yeah.
For a minute. Thank you. What he's essentially trying to do, I mean, I've got the metabunk stuff up here now. So if I put my first turbine in, let me just get the distances up now for the far one, 21.3. So I'm going to put 21.3. The hidden is 166 feet, right? That's what your mathematics says, that the first turbine should be missing 166 feet of it, right? When I put 23.7 to the furthest turbine, 226 feet. That's 34, 54, 55 feet difference, right? So that's from my observer's
I've got to stop
point.
you. It's not the hidden value, it's the drop value. We're talking about the geometry of it on the build, i.e. where it's built on the Earth. So it's the drop value you must look at.
Okay. 21.3 then to the first one is 302. Drop in feet, 302 versus 374. So we're talking 72 foot of drop over that distance. But if we do it like he wants to do, which is just the distance between 1 mile, let's put myself at 0 feet. So the distance to 1 mile, the drop is 67 feet. And the distance to the one after that, which would be 3.7, no, 4. 4. So the drop would be 10 feet. So essentially, he's trying to knock off 64 feet of drop by doing it that way.
Right, he just wants to look at them in isolation. That's all these globe heads want to do. That's why I did my little ball demonstration. Not because I wanted it to scale, but to demonstrate that this is a squared function. As it gets further away, it becomes more pronounced. The curve gets bigger. We don't see any curve in any of them at all.
Yeah, you're right that the curve gets bigger the further away it gets.
Excellent. We don't see that in the pictures, though, do we?
Yeah, you just conceded that. You just
let him
said
answer.
no.
Arwin, let him
right,
answer. Let him
but
answer.
you should see.
Arwin,
but you don't.
Arwin, let him answer. We don't see that in the actual photos of the real world, though, do we?
Well, you didn't let me finish the second part of what I said.
You conceded that the curve should get more pronounced as you get further away from it. That is our point. You have now conceded that. We do not see that in the images of the real world, do we?
And when you're talking about the distance of them getting further away, yes. But whenever you see them...
Sorry, we don't see a curve in the images. Why have you just said that we do? Do not lie to me, you little turd. We don't see any curve in the images.
No,
Yeah,
but he wants to
not let me
take us
finish.
to the he wants to take us to the distances between the actual build of the turbine, so that he can essentially say there's hardly any drop. But what he's forgetting is that from the observer point of view, we should see a huge drop from that distance. That's what we should see, because I'm filming it from my location. So that's what we need to account for. I'm not standing by the turbine, the first one taking it. I'm standing 20 odd miles away from it.
We did
So
this
I should
yesterday.
see a cumulative 72-foot drop.
This
That's
guy's
what
a
I
circle
should
jerk
see.
asshole. In fact, I'm going to kick
Well,
him
then,
out.
can I ask
Which
you?
one is
Can I
he?
ask you a question then?
No, I'm going to kick
No,
you out.
this is yesterday part 2. Go and watch yesterday's show.
Are you
No,
Mark?
I've seen it, but I still
Which
think that
account's
you
he
guys
on?
are incorrect in what you're saying. So
Which
I just
account's he
wanted to
on,
ask one
Mark?
question.
Goodbye, Mark. Don't circle jerk us around for 3 hours with the exact same crap you gave us yesterday. Get out. I'm not having an identical replay to yesterday's show because this asshole wants to assert that we don't see curve where we should. In his global model, we see no curve.
That's right.
It's really tough to try and get through to these guys. It's like they willfully ignore the obvious.
Hello.
You know, let's put it another way, right? So if we were looking at an observation of the Isle of Man, let's suppose we was trying to look at the lighthouse from the Isle of Man, right? And we were trying to film it, and we could see that there was a drop of 72 feet difference, right, by metabunks. They would claim, obviously, from the observer point of view, that you're losing 72 feet, right? We wouldn't say, oh, well, we put ourselves right next to the lighthouse, would we? The actual, from the viewer point, drop is the actual viewer point drop. There's no other way about it. You know, this guy is obviously here just to troll because it's so simple for him to understand.
I think he is trolling.
I don't think it is simple for him to understand at all because he just wants to see it. He just
Well, he's
wants
conceded it,
to
Arwen.
see it.
He conceded it twice or 3 times on this show. So he knows that we've got them by the short and curlies, but he just has to obfuscate. So when I say we don't see it in the image, though, he says yes, we do. He just lies.
He's hanging on by his fingernails.
He actually said, no, you're right. But then he backtracked within his same sentence. It's crazy.
That's only because he wanted to make his point. He was saying yes, and then he wanted to make his
No, he said, yes, you're right, but we do actually see it. He literally said that.
No, I know, but the reason why he said yes was to move on to his denial. He was just
Yeah, but
acquiescing
that doesn't
to
make
a
any
point.
sense if you're going to say, yes, you're right.
I know.
Yeah, that's why I kicked him out, because he's basically engaging in double speak, admitting things and then immediately denying them in the next breath. And we've done this yesterday for 3+ hours with that guy.
Can I share something with you guys that I find really absurd?
No.
And it's quite. What do you mean, no?
I'm only joking.
That's a bit
Just
harsh.
trying to break the
I've been
mood.
really nice.
Just trying to lighten the tone, that's all. I'm being quite stroppy because it's hot.
I know, it's fine. Right, so let me open this up. All right. Am I on? Am I on, Nath?
Yeah, sorry, I muted instead of unmuting. Sorry. Yes, you are.
Right, so I released a short video. It was only 2 minutes worth the other day, and it's now available in Italian. Shout out to Dino for translating it. But anyway, basically, if you haven't seen this video, go and check it out. It's a really straightforward concept. It's one of these repeating observations where I was challenged to go back and get it. I can't actually remember who it was that said go back and get it, but point is, along the way, I present on screen here the Metabunk curve calculator. Now, in the Metabunk curve calculator, for those of you that don't know, I'm sure it's everybody apart from Ruhif, it states clearly that you have 2 variables that you put in. You put in your distance in miles, and you put in your viewer height, whatever the viewer height may be. Now, I'm sure they'll add another 100 feet to mine, but in this case, I'm claiming it's 40 feet because, it's about that. Anyway, there's only 2 variables to put in here, distance and observer height. And in the results, you get this refracted hidden elements that we all know. This deals with the standard refraction. So, to my surprise, when I started to read through some of the comments, I spotted Ruhif's comments in amongst here somewhere. So Ruhif says, and I'll make it bigger so you can see it. Ruhif asks a day ago, date and time, question mark. So I thought, and why would that be relevant? Obviously, I knew what he was going to come back with. Weather conditions, go watch my latest video. And I thought, hang on a sec. You can't claim that, hang on. So Ruhif's an accumulated curvature denier, but you can't claim that you're going to now make a further adjustment for weather conditions when your own curve calculator has already addressed the refraction. So what Ruhif wants to do is recalculate and readjust for the refraction, but the only two variables that go into the curve calculator are distance and observer height. But Ruhif wants to now know about the refraction, but it's already been considered, and I used the value that was considered. But Ruhif now wants to recalculate for refraction a bit more. So you give them a bit of refraction, which is based on a presuppositional R and bendy light that doesn't even do it. But now Ruhif wants even more, but it's already been dealt with. So let's just put the record straight. The only two variables that go into the curve calculator is the distance and the viewer height. And the refraction argument falls flat on its face because it's already been adjusted for Ruhif. Do you understand that you can't make another adjustment for Ruhif refraction? It's already been dealt with, and it's already based on a presuppositional R. It's based on bendy light. But you want a bit more because it's not counting for it? I don't think so. Come up with your own calculator that deals with refraction if you can't accept this, because this is the one that everybody seems to use. This is why we're using it, because we can debunk the ball earth model with the Metabunk curve calculator. I'm done.
Have you found any curvy water yet? Has anyone found curved water yet?
Yeah, it's everywhere. You just can't see it because it looks straight.
Oh, have we not done housekeeping today?
No.
Curvy water. Yeah, Slice Barcane thinks that I've got curvy water in my videos, and when we challenged him on it, or when I challenged him on it, he ran away.
You've got curvy water. You need to go to the doctor.
So I think we can claim that Slice Barcane's claim for curvy water has gone out the window now because he ran.
They're all running. They're scared.
Well, they don't really see. This is where the only bit, Ranty, that you didn't make clear on your demo right at the beginning. I was listening. Was that if you guys are going to claim that it's curvature of the Earth that's causing the base of the towers to disappear, right? That's the claimed cause. If the claimed cause can be falsified with evidence to the opposing position, then it means that you're failing to prove that it's curve that's causing what we see. And at the end of the day, like we showed with the horizon on the Soundlies and the bridge, we can show that we can recreate it over a short distance on a flat plane and get the same effect. Well, we can recreate that by showing Zach's video, showing that the horizon does do the same thing on a short distance on a flat plane. So that brings into question the claim that it's curvature causing it, because the claim of curvature being cause is falsified by presenting evidence to the contrary. Whether you accept the evidence to the contrary is another a matter of opinion, but nonetheless, it's bringing enough doubt over the claim of causation to make the claim of causation dubious, therefore questionable.
Well, don't you think that also the work that we're doing, where the balls are just sitting on the hands and they're not actually doing anything, they're literally stagnating in their own belief system. They're not willing to go out and perform experiments to back up their argument. Whereas what we're doing is we're going out and formulating counter arguments to their belief system and what they've been indoctrinating us for the past 500 years. And we're actually going out and proving them to be false. And they're not countering with anything. They're doing the same old arguments that we have debunked.
If causation can't be proved, then it can't be proved. And at the end of the day, there's a preponderance of evidence out there that shows that the claim of the curvature of the Earth is questionable. If you check on Taboo Conspiracy's video recently that's going around, it's something like 77 proofs that need to be explained. I mean, there's a lot there. So, I mean, you've got Dubai's 200 proofs. We've got Taboo's 77 videos proving that we don't seem to see a spheroid Earth. Come on, where's the claim or the evidence for this curve? Because enough people are getting enough evidence to question it.
Can't see it because it's all looming into a flat plane.
Mark Lane, we counter with reality, but you reject it. Bring it to the table. We've been asking for the past 6 months for you to bring something to the table that we can look at, digest, and go back and take the blue pill instead of swallowing the red pill. So the invitation's there. Mark, Elaine, bring your ball earth proof, your reality that we would be rejecting, bring it and show us.
We get
so
models.
we can all go back to sleep again.
We get models. We get shown models. That's what we get shown. And when we look at the models in detail, like yesterday with that guy I just kicked out, he showed us that it should be curving. And that's because it should. Close, far, doesn't matter. If it's curving, it's curving. If it's built on a curve, it curves. And we don't see a curve ever. That's the bottom line here. These turbines are fantastic because they're all the same size in a row, and you've got differing distances for differing turbines. So you've got things that you can compare. You can scale it. And you can say, if it's a squared function and we get an increasing amount of curve the greater distance, then we should see it. And we don't.
There are no straight lines on a flat plane. On a ball earth.
Hey guys,
Curvature's not linear.
I posted in the Google Hangouts a couple pictures. I was Googling yesterday if I can see Dominican Republic from Puerto Rico, which is over 100 miles away. And I found a bunch of hearsay story, including Wikipedia and a New York Times Post report. The Columbus Lighthouse is the biggest lighthouse in Dominican Republic. It's 10 stories high, but it shoots up a laser that forms a cross in the sky. It looks by the picture like probably a mile high. Now, if you can see from Puerto Rico to the west, very point of the west coast of Puerto Rico is 172 miles. It's only 45 foot, the highest peak in that coast. That's 172 foot. 172 miles away. It should be like 2.5 miles of drop. Now, if you want to see it from the highest peak of Puerto Rico, that's in the middle of the island, and you can see from there, it's like 220 miles away. So it's ridiculous. I'm trying to put it away, trying to find real video, pictures, evidence of it. There's none. It's just a story as hearsay. Everybody's saying that they've seen the cross from Puerto Rico, so I don't know what to make out of it. It's probably true because Earth is flat.
Cool.
Absolutely. And I think with that, I'm going to say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, you know exactly what to do, but if you liked the show, maybe consider sharing it with a friend or subscribing if you've not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!